This module aims to explain the concepts of propositional logic and its application in inductive reasoning and economics. Definition of a proposition. A proposition is a statement, assertion, claim that has the following defining features. It can either be true or false. If a true proposition is true, then we say that it has a true value. And if a proposition is false, we say that its truth value is false. Propositional logic deals with the relationship between propositions. In propositional logic, we construct compound claims out of a set of basic logical connectives and, or, then, etc. After studying this module, you shall be able to know the concept of logical connectives and truth table, explain logical connectives and their truth table, understand logical inference, and link logic and economics. Let us initiate the model with the study of logical connectives and truth table. Logical connectives are operators on propositions which make propositions more complex. 5 types of such operators are conjunction, P and Q, disjunction, P or Q, negation, not P, implication, if P then Q, biconditional, P if and only if Q. A truth table is a tool used to represent the relationship between the truth values of a compound proposition such as P and Q and the truth values of its individual components PQ. Next, we will study explanation of logical connectives and their truth tables. Conjunction operator. For example, P stands for this TV show is interesting and Q, I am watching this show. Here, P conjunction Q stands for this TV show is interesting and I am watching this show. The conjunction PQ is true if and only if both P and Q are true and is false otherwise. Next, we will study disjunction. For example, P stands for caterpillars are green and Q stands for caterpillars are red. Then P disjunction Q stands for caterpillars are green or caterpillars are red. The disjunction of P and Q is the proposition that is true when either P is true, Q is true or both are true and is false otherwise. Thus, the proposition V is inclusive OR. Next, we will study negation operator. For example, P stands for this quilt is warm and negation P is this quilt is cold. Only one of the propositions P or negation P can be true at a particular time. Next, we will study implication operator. For example, P stands for if you study 5 hours for macro exam and Q stands for you get 90% marks. Now, if P is true, then Q is true. That is, if P then Q. Therefore, P implies Q is true when P is true and Q is true, or when P is false and Q is true. The truth table is as follows. When P and Q are both true, P implies Q is true. When P and Q both are not true, but one is true, the other is false, then P implies Q is false. When P is false and Q is true, P implies Q is true. And when both are false, P implies Q is true. Next, we will study biconditional operator. For example, P stands for you are new in college and Q stands for you don't know where the bathroom is. Then P if and only if Q means that if you don't know where the bathroom is, then you are new in college. Or if you are new in college, then you don't know where the bathroom is. Truth table is as given in the figure. If P, if and only if Q is true, then P implies Q. and Q implies P are both true. Conversely, if both P implies Q and Q implies P are true, then P if and only if is also true. Now we will study necessary and sufficient conditions. As explained the meaning of implication operator and the biconditional operator, there are other commonly used ways of expressing that proposition P implies Q or that P is equivalent to Q. If P implies Q, we can say that P is a sufficient condition for Q, in the sense that for Q to be true, it is sufficient that P be true. Also, we know that if P is true, then it is certain that Q is also true. Thus, we say that Q is a necessary condition for P. The module presents two simple examples to clarify these terms. Example 1. A necessary condition for a figure M to be a square is that M must be a rectangle. However, if M is a square, then it is a sufficient condition for M to be a rectangle, since all squares are also rectangles. Example 2. In microeconomic theory, an indifference curve shows the bundle of two goods that give the consumer equal utility, that is satisfaction from consuming a bundle of good. Therefore, a falling MRS is a necessary as well as a sufficient condition for convexity of an IC. Now let us study definition of an argument. An argument consists of a sequence of statements called as premises and a conclusion. An argument is valid if the conclusion is true when the premises are all true. Meaning, if you agree with the premises, then you must agree with the conclusion. Arguments are used to find out the truth about a situation, given its various facts which are used as premises. Example, my printer is out of ink or my printer is malfunctioning. I refilled my printer's ink yesterday and haven't printed anything. Conclusion being, my printer is malfunctioning. Arguments use various individual and compound propositions in their usage. Now moving on to logical inference, the definition is, it is an act or a process of deriving logical conclusions from premises which are known to be true. Inductive reasoning or bottoms-up approach to a reason. When an argument is made based on the premises, it may not be true in all the cases. In such a situation, the reasoning is said to be inductive in nature. Inductive reasoning is successful only if enough evidence is available to test the validity of the conclusions made. It draws inferences from observations in order to make generalizations. Example, we have seen hundreds of cows while driving through Gurgaon. Every cow we have seen has been white. Therefore, every cow in Gurgaon is white. Inferences made through inductive reasonings may be true in most cases, but there may be certain exceptions. We now see how economics uses logic and proposition in its field. In this century and the last one, we have had the advantage of collecting data to develop a particular theory on logic. Before modern times, economic theories were mainly conceived by thinkers by way of conjectures about various economic variables based only on introspection and casual observations. Logic is a study of reason, and hence it can help us find the fallacies in any given argument. Economists often give various arguments to explain any particular phenomenon. Hence, a sound knowledge of principle of logic is essential so as to separate the wheat from the chaff. Adam Smith, 1723 till 1790, is considered as the founder of modern economics. Through deep examination of world affairs, Adam Smith found that collectively all individuals in a society, acting in their own self-interest, manage to produce exactly the quantity that they require. Of course, Smith couldn't prove the existence of invisible hand
in his celebrated treatise, The Wealth of Nations, 1776. They are after all invisible. But Smith provided many instances in his book. He quotes that it is not the benevolence of the butcher, the brewer, or the baker that we expect our dinner, but from their regard to their own interest. Essentially, Smith promotes that in a free market, the quantity of goods and services actually produced exactly matches the requirement of all buyers and suppliers. This is after taking into account their payment ability. He argues for a laissez-faire attitude by the government towards the marketplace, which will stimulate greatest good for the greatest number of people. Thus, we see that Adam Smith uses inductive reasoning, observations of world events, to form premises that then form a conclusion in order to develop his ideas, which would go on to inspire generations of economists and policymakers. Next, we shall see another example, example 2, Karl Marx dialectical logic. Karl Marx 1818 till 1883 was a German philosopher, economist and a social scientist. Marx used principles of formal logic very extensively in developing his theories. However, his logic of dialectical slightly deviates from formal logic. Formal logic is based on principles of non-contradiction. It is a fundamental assumption that if P is true, then not P is automatically false. However, these principles are very narrow in scope and involves various assumptions about the real world. In Marxian view, contradictions can exist in an object. In fact, Marx argued that every object has a thesis and an antithesis, and it forms a struggle of these two forces that synthesis is created and a thing is transformed into some other thing. Thus, Marxian understanding of the world is through an evolutionary process of contradictions. Marx used his process of dialectical to understand the fundamentals of various modes of production that arose during socio-economic developments of societies ranging from feudalism to capitalism to socialism. Marx predicted that internal contradictions of capitalist system, which create recurring crises, will eventually lead to a fall of capitalist structure and the rise of socialist structure, in which the means of production, that's raw material, machinery, equipment, factories, etc., will not only be owned by a reserved class but by all the members of the society. Thus, we see the importance of logic in the dismal science of economics. Economics is a social science which deals with both real-world principles and people. Both behavior cannot be predicted in any lab. Principles of formal logic provide the underlying groundwork for all the other theories. Logic is a study of reason, and hence it can help us to find fallacies in any particular argument. Economists often give various arguments to explain why particular phenomena. Hence, a sound knowledge of principal logic is very important to separate the wheat from the chaff. Now let us summarize what we have learned in this module. Firstly, a proposition is a statement, it's an assertion, a claim that has the following defining features. It can either be true or false. If a proposition is true, we say that its truth value is true. And if the proposition is false, we say that its truth value is false. Logical connectives are operators on propositions which make propositions very complex. The conjunction P, Q is true only if P and Q are true and is false otherwise. The disjunction of P and Q is the proposition that is true when either P is true or Q is true, or both are true or false otherwise. If P implies Q is true, then P implies Q and Q implies P are true. Conversely, if both P implies Q and Q implies P are true, then P if and only if Q is also true. An argument consists of a sequence of statements called as premises and a conclusion. An argument is valid if the conclusion is true and if the premises are all true. Inductive reasoning is successful only if enough evidence is available to test the validity of conclusions thus made. It draws inferences from observations in order to make generalizations.